We are built at the 100 acres, on the 100 acres of land, 95% of the land is used. Just out of these 625 local, is actually most are the Malaysian Malay. I would say 95% is Malay because of we are actually at Kuantan. Kuantan East Coast, most of the people are Malay, and people from Kuala Lumpur, from Selangor, reluctant to go to Kuantan because we used to hire one engineer last time, very young engineers. We say that Kuantan is very nice place. We say that, but after 3 months he resigned because he said that Kuantan do not have nightlife. So I told them our nightlife is surau and masjid. Okay, but that doesn't interest the young people. But not all those. We have some people from Fatahia is from KL. Probably also from KL. So probably also now because of the age, their nightlife is surau and masjid. So I think we should pay there. Just to get some clear picture on how the plant operates is, I'll show you the video, which most of it will show you the operation area.
Infinite possibilities define our future. Discerning consumers and expanding industries demand more, demand better, and demand smarter products. It is a future where energy-efficient products will spearhead a greener environment and more advanced digital technology. That future begins here. Lynas Corporation, bringing rare earths from mines to markets globally, owning the world's richest deposits of rare earths at Mount Weld, Australia, to our completed state-of-the-art production facility located at Gebeng, Pahang, Malaysia, commonly known as Lynas Advanced Material Plant, or LAMP. We are strategically positioned to expand production and broaden product portfolio to meet global market demands, forging strategic alliances, ensuring customer contracts, maintaining industry partnerships. The future is promising. A future possessing vast potential. Rare earths, abundant yet varied in concentrated levels, but at Mount Weld, Australia, rare earths are made up of 15 elements, processed and shipped to Malaysia, separated for their individual or combined commercial use. Rare earths play a pivotal role in greenhouse gas reduction. Our products will spearhead the advent of new technologies. From automotive catalytic converters to hybrid vehicles. From wind turbines to energy-efficient compact fluorescent light bulbs. The potential is infinite. Lynas Advanced Material Plant, a first-class, state-of-the-art production facility that can produce up to 22,000 tons of rare earth annually. Arriving in concentrated form, the earth will undergo various processes. Such as cracking, separation, and neutralization. Upon completion, the final product is ready. Rare earth. Waste residues are also processed, creating synthetic mineral products such as road-based materials, gypsum boards, as well as fertilizers. We are committed to ensuring the sustainable development of the environment and the organization. Subsequently, Rare Earths Direct was formed to establish our very own brand. Our brand ensures maximum profitability across the value chain. The Lynas strategies are: create a benchmark for the security of supply and setting environmental standards in the global industry. Whilst making significant investments, we shall protect the environment and the communities where we operate. Safe for people, safe for the environment, and secure for customers. Wastewater treatment facilities, gas cleaning systems, dust collection systems, solid waste management systems ensure high levels of safety. We are constantly striving to achieve our goal of zero harm through a safe working environment. In being innovative, we are finding new ways to create sustainable development outcomes. For a greener tomorrow, a smaller carbon footprint, community developments through jobs, education, local community groups, and sustainability-related initiatives. We are opening up new possibilities. We are strategically positioned for excellence. We are forging ahead into the future. Lynas, delivering rare earths globally.
Okay, that is part of the story on Lynas manufacturing plant. I like to show this video because my face is there. But it looked like it's very young inside there because it was like in 2013. The time I haven't converted myself to a golden citizen. So this year I reached 60, so I'm very golden citizen. Okay, I think it's not nice just I myself talking alone without you responding. We allow you to ask any question if you want to. You want to converse me to converse in Bahasa, I can do that. No problem. Okay, in this slide, it's talking about rare earths is actually green technologies product. We are promoting green technology product that will replace somehow the current fuel or current energy, which is not really friendly. The other side is actually the product, the list of product It can be used in turbine. This turbine, talk about turbine, is actually the magnet. This is the magnet. PRNE is the one that produces, can be made into a magnet. And then I think this one product, we'll talk product later on that more detail. This is the what is this called? Periodic table. I learned this in 1977, so I don't remember. But the one that I want to show you is actually here. This lanthanide series. The rare earths contain all these materials, and Lynas Malaysia is actually extracting these to become a product here. We bring along the product that we have produced in Kuantan, and we will show to you later on that. You can touch if you want to touch. Don't worry about radioactive. It's not that much as what anti-Lynas says. So it's there. Everything is there. Okay. Let me hand over to Azam before I continue with others. Azam will talk about the manufacturing, the production.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning to all of you. Thank you, Mr. Jumat, and thank you all the participants, because you're interested to Lynas, to know more about Lynas. It actually honored me to present to you today, because as you know, Lynas been spread over Malaysian with negative and also with positive. I'm joining Lynas on back to 2010. During those days, I'm joining during the scratch, only piling during that day, and I built up Lynas I think last 9 years, and I'm also one of the radiation worker in 2000, I think, if I'm not mistaken, in 2014, been a radiation worker until now. And I'm facing a lot of problems with the communities and with the so-called SMSL, the anti-Lynas group, that in fact, not me alone. I feel when I start joining Lynas, it also affect, I think, my family. My son in school also being tortured by their friends because their father working with very bad company, and in fact during those days, the political group take advantage on the Lynas, and I think because of that, we faces a lot of challenge, and I'll tell you, I'm working 24 hours to get this done. Okay, anyway, okay, this actually the concentrate that been sent from Mount to Malaysia. This actually ordinary like normal soil. They bring from Australia with 2.3 metric ton bags. They bring to Port Kuantan, and from Port Kuantan we are taking by container to Lynas. Okay, this is the rotary kiln that in the corporate video just now. Actually, this we have 4 rotary kilns. Later on, I will detail out on how that the rotary kiln operates. Okay, this is the solvent extraction. We have the rotary kiln is part of cracking and leaching process, and this is the solvent extraction. This is we call the batteries that separate the rare earth individually. Okay, we operate with the fully automated process and control from the control room. We have 4 control rooms. Sorry, I'm the manager for the offsite utility and residue, and we have 4 plants and 4 control rooms, and the control room is fully automated, meaning to say that we are control all the process inside the control rooms. We have automated valve and everything, same like the oil and gas industry. Okay, this is the simple flow chart for Lynas process. Lynas plant is not complicated as other petrochemical plants. Lynas plant is heavy chemical plants, but it's not complicated. It's just simple plant with no high pressure. We only got high temperature. Okay, the simple flow sheet. We are mine and crush at Australia and concentrate the lanthanide or rare earth that we got from Australia. Concentrate at the Australian plant on the flotation process, and we increase the amount of rare earth inside the lanthanide around 37 to 43%. With around 17% of moisture. Why that we limit at 37 or up to 43%? Because when we are doing the concentration, amount of the radioactive material also inside the lanthanide, then it will also increase the level of radioactive. When we flotation and concentrate the lanthanide, the level of radioactivity is about 6.5 becquerel per gram, which is Malaysia regulation, ALB regulation, material with more than 1 becquerel per gram is considered radioactive material, but part of the other country like Australia, 6.5 becquerel still not considered as radioactive material, because in Malaysia, when we ship to Malaysia, then we put a plate cup for radioactive. Okay, then we have cracking and leaching plant, separation and product finishing, and this is actually the various product that we have. We have LACE, lanthanum cerium carbonate, LACE oxide, cerium oxide, cerium carbonate, lanthanum oxide, SAG, samarium, europium gallium oxide, and also NdPr, PRND. This is the most, it is about 25% of our product composition, but it is the most valuable product that we have. Okay, this is a general process as I explained just now. From Australia, what will they do as Australia? They are grinding and crushing, and they do the flotation process, and after that they are separating the liquid and solid throughout the filter press, and with the up to 40%, 27 to 40% of REO, and they are sending to Malaysia via ship. And we are collecting at Kuantan port with the container, and at the Kuantan plant, from the concentrate, we are mixing with the sulfuric acid. We are using 98% of sulfuric acid to mix the concentrate before we crack. For the lanthanide actually in phosphate form. When we are mixing with acid sulfuric, the temperature is rise up to 150 degrees C, and after that we are sending to the rotary kiln that you see in the picture just now. we have two rotary kiln that is around 60 meter length with 3.5 meter diameter. What the rotary kiln do? Inside the rotary kiln, we are burning the mixing of acid and concentrate up to 1000 degrees C. And what happened inside there? We are mixing with the acid sulfuric. The form of the lanthanide is changing from the sulfate form to from the phosphate form to the sulfate form, because later on it is easy to dissolve to separate the element of the rare earth. Okay, along the line when we are baking the concentrate up to 1000 degrees C, we also producing the gases, the hot gases that entering the waste gases treatment plant. And after that we are leach. We use a lot of water to leach. We are, I think, at the Gabang area, the most likely the second largest water usage of Pahang right now. We use around 500 cubic meter per hour of processed water. Comparing to the MC KIP, they are using around 1,300 cubic meter per hour, the processed water. Anyway, thank you to Pahang State, because they are able to have the facility, to improve the facility to cater the water usage, because I think in last 2-3 years we have a few hiccup of water usage and causing our plant breakdown. When we break down for one day, we will lose, I think, around 2 million AUD per day. Okay, from the rotary kiln, we mix with a lot of water to leach the rare earth, and we are separated the rare earth within the solid and liquid throughout the pressure filter. During this process, we have primary leaching, secondary leaching, and also tertiary leaching, and we refine the REO up to 18 GPL, more than 18 GPL, and the REO less than, I think, less than 2 GPL. It is we are sending to the WLP. This is the first part that residue generated. We call is WLP, water leach purification, and this is coming from leaching process. When we are separated from liquid and solid, the solid actually is the first waste that we have, which is contain the intrinsically low level of radiation. It's about the 6.5 becquerel per gram. Remember, when we are bringing from Australia, the radiation level is at 6.5 becquerel per gram, and within the process, the radiation level is not increased, meaning to say that there is no concentration at the Malaysia plant. And when we are discharging to the WLP also have 6.5 becquerel per gram until now. Okay, and after cracking and leaching plant, they are going to the solvent extraction plant. Actually, this is the gist of the rare earth plant, because Malaysia Lynas, for your information, only Lynas is the first integrated plant in the world. Meaning to say that in China, there is some part to do the upstream plant, and another company to do the downstream plant. But Lynas is the first integrated plant that will build a downstream and upstream plant at the one places. Okay, the SAC is based on the solvent extraction or the liquid separation, whereby the base of the process is the relative solubility into immiscible liquid, meaning to say that we are separating the rare earth, the liquid rare earth inside the organic and inside the aqueous with along, I think around 110 batteries. We have SX1 up to SX8. The principle is like the distillation column, whereby inside the distillation column is the vertical part, but our distillation or our separation is on the horizontal part. And we have, for example, SX1, SX2, SX3, and up to the SX8. SX1, we are producing the heavy rare earth, we call SEG. And for SX2, we are, during SX2, they are washing the rare earth and sending to SX5. Inside SX5, they are separate the rare earth to lanthanum and cerium and PR and ND. SX6 during and goes to SX6. SX6 they are separating the process from Na and from Ce. And after SX6 go to SX7, and at SX7 they are the process purified the PR and ND. And this technology actually we collaborated as earlier slide from French, and this is a very rare technology that we have, and I think Malaysia is lucky to have this technology in Malaysia, because as mentioned by Cik Jumaat, we also have a lot of stock rare earth inside. I think especially Perak, Pahang, Terengganu. Okay, I want to talk about the gases that we are treat at cracking and leaching plant. Okay, as you know, when we are I already mentioned to you about the gases that exit from the rotary kiln. It is about 200 degrees, 280 degrees C, and within the wet waste gas treatment plant, it is built with this PVC and also CPVC. Basically, all the built-up material is within with the plastic material, and we have the venturi scrubber there. Venturi scrubber is actually to chill the gas. We are exit the gas is about 280 degrees C, and we are chilling down the scrubber less than 110 degrees C. And we have the spray tower. The spray tower is actually to remove the SO2 gases. And within the spray tower, we inject the line within the spray tower and up to 5.7 pH, and remove the SO2 gases, and SO3 gases is removed by wet electrostatic precipitator. This is, we are using direct current to inject inside the electrostatic precipitator. It will react with the aerosol particle, and we track the aerosol particle down to the bottom of the WSP, and the result is we are producing very clean gas. The total particulate material we are controlled less than 50, SO2 we are controlled less than 100 ppm, and SO3 we are controlled less than 50 ppm. Meaning to say that no hazardous gas, no toxic gas is exit our stack. And also in your mind, I think we are dealing with the radioactive material. And what about the Toron and radon gas? We have the aerosol monitoring system within our premise that detect any radon and Toron gas escape, and so far there is no reading actually. And we also have one more aerosol monitoring system at the Balai Polis Kuantan, which is also the same reading as at Lynas. Okay, the last plant we have is the wastewater treatment plant. Inside the wastewater treatment plant, what we do, we are neutralizing all the wastewater that produced within SX, PS, and also cracking. Because remember, we are using a lot of water, 500 cubic meter per hour. Then we need to treat a lot of water. We are treating with the hydrated lime, calcium hydroxide, and also we use the thickener to separate the solid and liquid. And the overflow water is sending to the Search Lagoon, and after that to the Sungai Balok. And the wastewater we are controlling within the 31 parameters of DOE. And so far, I think as we are auditing by every part of government bodies and also the third parties, and so far I think starting from 2017 and above, 2016 and above, we are, for the wastewater, we are complying 100% of the wastewater. Before that, because we have a few hiccup, then we are a bit high, one or two, I think two occasions in 2015, a bit high on manganese during that time. That is around 1.3 and 1.2. The manganese should be less than 1.0 ppm. Okay, the last part is the product finishing. The methanol is actually for the feed to the bacteria, because for the wastewater, there is two part of wastewater treatment. There is physical, chemical reaction. This is representing this part, and also biological reaction. We use methanol, urea, and also the phosphoric acid to feed the part inside, because we want to control the COD and the BOD. The BOD is less than 50, the COD is less than 200. And also we need to control the TSS. TSS is less than 100 ppm.
So is there any more remnants of the methanol?
No, there is no, because the methanol actually at the sequential batch reactor only. That doesn't change very much. We checked the clear well. There is no presence of methanol actually. The methanol only feed to the bacteria that we use inside the SPR. Okay, we have another group of residue from the process of the neutralization of the SX PF SX liquid. We call the NUF, neutralized underflow. And neutralized underflow we are sending to the RSF. And RSF, and we currently two residue, NUF and also WFP, is part in our plant. We are receiving the permanent disposal approval from the DOE to dispose NUF material inside our plant, whereby for the WLP, as a government recent condition, we need to find the new PDF for the WLP material, which is we are progressing to do that right now. Okay, this is the lanternite as explained to the from Jumat earlier. Okay, you see our product is used for the lantern cabinet for the 12% for the hybrid car, and SEG actually is used for the efficient lighting, and the LACE for the polishing powder, and Syrian cabinet for the catalytic converter. Inside our car there is below our car there is a catalytic converter. I think the car maker start using the catalytic converter starting 1985 and above. Okay, a lot of things that we do, that we use every day is actually from rare earth, whether we realize or not, but we need to use the rare earth. Okay, this is the same, and the rare earth also used as the catalyst inside the diesel, whereby when you are using the rare earth as a catalyst, the diesel actually the rare earth actually track the soot and improve the filter for the engines. Okay, this is our customer, our various customer all over the world. Recently we have I think one customer in Malacca, the first customer that we had inside Malaysia, but whereby this one is all outside Malaysia. The most customer is from Japan. Okay, you want to continue this one?
Thank you, Azam. Okay, I think I need to do some sanity check over here.